Hey, I know what you're thinking. You're wondering, I wonder what the derivative of the height function of that shot looks like.
So here is a graph of Jonathan's shot, the height of the shot and the time. There are two interesting times in Jonathan's shot. There's the time which I called R, at the point at which the ball hits the rim and then bounces upward a little bit, and there's a time which I call B, standing for bounce, when the ball bounces. So we're tasked with thinking about the derivative of this shot. And so I want to think about the derivatives using slopes of tangent lines. So how does this shot start off? It starts off with an initial velocity represented by that tangent line, which is some positive number. So in the beginning, we have some positive initial velocity of our shot. Eventually, the vertical velocity is 0, represented by a horizontal tangent line. So that's somewhere right about there. So the graph of this derivative should do something like that. And then, as it approaches R, it gets to some negative value. So we'll just say maybe somewhere about right about there. On the other side of R, it changes abruptly to a positive slope, or an upward velocity of some quantity. Eventually, again, the vertical velocity is 0, right about here. Then it goes down to the ground, and right before it strikes the ground, it has some downward velocity. Right after it strikes the ground, it has some upward velocity that heads towards 0. So I know it ain't pretty, but that is what the derivative of Jonathan's shot would look like.
That was a pretty good one.